Okay, this problem says find x given that the distance between x comma negative 2 and 5 comma 3 is the square root of 41. So it gives you these 2 points and it tells you that the distance is the square root of 41. So we're certainly going to need to get an equation from that. And so, well, we're going to use the distance formula because we're given the distance. So remember that if you have these 2 points x1, y1 and x2, y2, okay, so in this case x1 is x, y1 is negative 2, x2 is 5, y2 is 3, then the distance from x1, y1 to x2, y2 is the square root of x2 minus x1 squared plus y2 minus y1 squared. And so we're given that this is the square root of 41. So now we plug in our information. So we get, okay, well, we square both sides to get rid of the square root. And then we plug in x2. So it's 5 minus x in parentheses squared plus y2 is 3 and then minus negative 2 squared is 41. So it's 5 minus x squared plus 3 minus negative 2 is 5. 5 squared is 25. So equals 41. Now in this case, we could distribute the 5 minus x. We could distribute that across, and that would be fine. That would give us the value of x when we solve the equation, but I think it's a little faster to isolate the square. So in other words, to get this by itself, and if we get that by itself, we can get x. So let's subtract 25 from both sides. So we get 5 minus x in parentheses squared. So 41 minus 25 is 16. And now we get 5 minus x equals plus or minus 4 because it's plus or minus the square root of 16. So now we're going to add x because we want to get x by itself. So 5 is x plus or minus 4. And then, okay, so let's write it as 5 is x plus 4. 5 is x minus 4. So for the first equation, we get subtract 4 on both sides. We get x is 1. So add 5 to both sides. For the second one, we get x is 9. So we get 2 values of x, 1 and 9. And let's check that they work. Both of these will work if you plug it into this original equation. Or I guess the equation is going to be this. Okay. So our 2 values of x are 1 and 9.